Okay, in this problem, we're going to deal with situations where we want to estimate a population mean when you know the standard deviation, when you know the sigma, the population standard deviation. So we're going to be given that piece of information. So in order to estimate the mean, maybe you come up with a confidence interval like this. The population mean is between two values. And the x bar is the sample mean. So you're going to take a sample and you're going to get a mean for that sample. That's what the x bar is. And then E is what we call the margin of error. And the way that you calculate the margin of error is you multiply the z alpha over 2, which you get from the confidence level, times this population standard deviation divided by the square root of n, which is the sample size. You're going to have some problems. They'll ask you for the interval, the range of numbers. Sometimes they're going to ask you how big of a sample should we take. In order to calculate that, you use this formula right here, where you do the z alpha over 2, which is dependent on the confidence level, times the population standard deviation divided by that margin of error, and you square it. And no matter what number you get, say you get 100.1, you would think, oh, I'm going to round down to 100. No, if you have any decimal component at all, you round up. So it would be 101. So that might screw you up if you think you got to round it to the nearest number. You always go up when you're calculating samples. Okay, round up. So here's an example. We have SAT scores. The mean is 1500. The standard deviation is 300. We want to estimate the average SAT score. So in order to do that, we have to take a sample. So that means they're asking us how many should we sample. So that's the n equation, like how many should we sample. So I'm going to use that equation. So you just got to look at each of the things in the equation and figure out that it's not a 6, guys, that's a sigma. It looks like a 6. What everything is. So z alpha over 2 for 95% confidence level, that's a very common one that they give you, 95%. I would just memorize that one, but it's 1.96, but we went over examples of how to calculate that. So it's 1.96. So 95%, 1.96. Times sigma. Sigma is this population standard deviation, which they gave us as 300. Divided by E. Oh, they gave us the margin of error. See, they actually gave us that. We didn't have to calculate it. It's 25. So you just pop it into that equation and you whip out your calculator. And what did I get? I got, let's look at the page here. I got 553.1904. So you go, oh, so if I'm going to round down to 553, no, remember, if it's in one of these end sample size, say we're talking about people, you can't have 0.19 of a person, so you always go up. You take the 554th guy sample. All right? So there's a case where I got an n, had a decimal component, you go up. If you typed in 553 into my open math, it would tell you you're wrong, okay? Because it's 554. So I hope that helps.